All right, what we are going to move into next is how to solve absolute value equations with graphs. So we are going to solve absolute value equations graphically. So you should be writing in your notebook along with me, taking notes. Now, the reason I'm choosing to do this next is it's going to reinforce what we just worked on with graphing, and it's going to open up doors to help us understand solving equations, which is what we're going to move into next week. So I'm not going to give you steps. I'm just going to show you how to do it. So for each of these, I just want the directions are just to solve. So number one, the equation is 2/3 the absolute value of x plus 1 minus 4 is equal to -2. So the first thing I will remind you is notice that we have something involving an absolute value and is equaling a negative number. Well, the reason that's possible is because of this -4 right here, so don't let that. Sometimes I think students see a negative and they automatically say no solution, although it is possible that there is no solution. If they don't cross, there is no solution. But what we end up doing is we graph both sides. So I'm going to make this side y equals 2/3 the absolute value of x plus 1 minus 4. So I'm going to graph that in orange. And then I'm going to graph the other side in a different color. It doesn't actually matter what color, just something other than that. Y equals -2 in green. And what I'm going to look for is I'm going to look where do those two functions intersect. And where they intersect will be my solution. So it's possible I have more than one solution. It's possible I have one solution, and it's possible I have no solutions. All right, so first, my vertex for my absolute value function is -1, -4. The average rate of change of both sides, or of the two sides, are plus or minus 2/3. And I know that this absolute value function is going to open up. So I am at -1, 1, 2, 3, 4. So -1, -4. And I'm going to use an average rate of change of 2/3 for either side, so plus or minus 2/3. So I'm going to go up 2, right 3, up 2, right 3, up 2, left 3, up 2, left 3. Now it could be that, I don't think that was quite 3. Oh no. Where's my vertex? -4, 1, 2, 3, 4. There. It could be that when you finish your graph that you have to go back and add more if you didn't graph enough for the function to actually show what you were hoping it to show. And I'll show you what I mean in just a second. So now I'm going to graph the line y equals -2. Oh, I never actually graphed my absolute value. Whoops. Let's go back and fill that in really quick. Sorry about that, guys. When I erased my axes, it threw me off. All right. So now I have my absolute value function graphed, and I have my horizontal line graph. Remember, if you just have y equals a number, you are looking for all of the points in which y is -2, and that gives us a horizontal line. Now, my actual answer to my question is I want the solution to the equations. So I want to know at what x value are the y values the same? Well, right here and right here, my y values are the same. That gives me two spots where they have the same output of -2. So my solutions, I'm solving an equation, are x equals -4 and x equals 2. All right, let's do another one. So number 2, the absolute value of x plus 2 minus 4 equals 2x minus 1. Hopefully this time I don't erase an axis. So Again, I'm going to graph both sides in different colors. I want to graph my absolute value function in one color and my linear function in another color. So I'm going to choose my absolute value to be in orange. So my vertex is at -2, -4. I know that the average rate of change of each side is either plus or minus 1. And then I know it's going to open up because A is positive. So -2, 1, 2, 3, 4. And then open up because A is positive. Now, if you have a straight edge, you might not have to put as many dots, but it is a lot easier for me to connect the dots than it is, excuse me, any other way of graphing. So now I'm going to graph the line y equals 2x minus 1. So this is y equals mx plus b form. M is your slope, so 2. B is the y-intercept, which is -1. When I graph a line, I start at the y-intercept. So I'm going to start here. And then I'm going to use a slope of 2. So I'm going to go up 2, right 1, up 2, right 1. And you can pretty quickly see that's not getting me closer to the function. So now I need to go the other way. So I'm going to go down 2, left 1. And oh, look, there's my intersection, down 2, left 1. So I'm going to go ahead and graph this. Now, we are solving, but if I ask you to solve graphically, I expect to see a full graph. So even if you get to the point where you know what the solution is, make sure that both functions are fully graphed. And my solution for this one is x equals -1. So in the first example, I had 2 solutions. In this example, I only have 1 solution. All right, we're going to do one more. Number 3, we have -2 times the quantity x plus 2 plus 3 equals x squared minus 1. Obviously, you can see this is taking it up a notch. Now we have an absolute value equal to a quadratic, although it's a pretty simple quadratic. It's still a bit trickier just because it is a quadratic. So I'm going to first start by graphing my absolute value. So my vertex is at -2, 3. My average rate of change of each side is plus or minus 2. And I know that it's going to open down. So I'm at -2, 1, 2, 3. And then I'm going to open this down, down to over 1, down to over 1, down to over 1. I'm going to do the other side, down to over 1. And there's my absolute value v. Now let's move on to my quadratic. So my vertex of this is at 0, -1. It's going to open up, and there's not a vertical stretch. So I'm going to put my vertex at -1. I'm going to go over 1, up 1, over 1, up 1, over 2, up 4. So 2 squared, 1, 2, 3. Oh, look at that. Over 2, up 4. Now, I like to graph quadratics that way. I'm going to show the other way just in case you don't. So x, y, so this is my parent function. So -2, -1, 0, 1, and 2. 4, 1, 0, 1, and 4. So you can also apply the transformations. We know that this -1 is a shift down 1, and that's my only transformation. So I could have plotted, so I just recopied my x's. I'm going to take each of my y's and subtract 1. And those are the 5 points I just graphed. I had like a faster way of doing it just because I know what the parent function looks like. But if you are struggling with that, you can always create tables to help you graph. All right, try your homework and email me with any questions. Thank you.